Hey class, a little bit of technical difficulty, but I'm finally getting around to these videos. I am going to go back and do homework number 1 even though there won't explicitly be questions about factoring. I still think it's useful for you guys to have it, to be able to watch it. So I'm going to do it. Your assignment is the odds, but unless I get really tired, I'm going to try to do the odds and then also do the evens for you. So if you don't care about the evens, they'll be at the end. So just cut the video. But I'll do the odds. So here we go. Taking a look at number 1, I'm going to go into more depth than is necessary to, just so you guys have that background knowledge. But looking here, this thing is a polynomial, and it's got 4 terms, and there's no special name for a 4-termed polynomial, but you should remember if there's 1 term, 2 terms, or 3 terms, it's a monomial, binomial, trinomial. You probably remember that, hopefully. After that, I don't think they get special names based on the number of terms. Then the highest power being 3 makes this a cubic function, as opposed to a constant function, a linear, a quadratic, a cubic, a quartic, a quintic. So up to 5. Beyond that, I don't think they get named by their degrees. Anyway, to factor this one, because it's got 4 terms, because you've got a coefficient of 1 and then 5, and then a coefficient of 1 and then 5, it certainly looks like I could factor it by grouping, so that's exactly what I'll do. We'll group the first 2 terms. And just be careful about how you group the next 2 terms. You've got to group the negative with those terms. And so just think about expressing this as adding a negative x plus 5. And then it's a plus sign that should appear between the 2 groups. Okay. Once you've got them grouped, you just factor out the GCF. So you factor out an x squared, x minus 5. Then from this one, you factor out a negative 1. You get x minus 5. And now you've got that same factor of x minus 5, so you factor that out. The same way that we factored out an x squared from here, you can factor out this whole binomial factor here, just like you can factor out anything else. So the x minus 5, if it factors out, then from this term, it goes away and leaves me with just the x squared. From this term, it goes away, leaves me with just the adding of a negative 1, which of course is just minus 1. Then you'd think that maybe you're done after all that hard work, but you're not, because you got to factor this difference of squares. And a difference of squares is the one that's always going to factor down to square root of that, which is x, square root of that, which is 1. And then those same terms again, x and 1. And when it's a difference of squares, you just alternate signs. There'll be one that's plus, one that's minus. And order doesn't matter. Order doesn't matter on any of this, okay? As long as you're giving me the 3 correct factors, I don't care what order they're in. So that's it. That's number 1. Let's do 3. So for number 3, it's 3 terms, so it's a trinomial. And we call this one sort of quadratic in nature, meaning it's like a quadratic in that your terms at least have the right ratio of powers. This is 6, 3, 0. A normal quadratic would be 2, 1, 0, like an ax squared, bx, and then c with no x's. Well, you can multiply this by anything. Here we see it's getting multiplied by 3, so it goes to 6, 3, 0. That's going to still be quadratic in nature as long as the leading term is twice as much as the middle term, and the last term has no x's at all. If it helps, you can make a u substitution here. We talked about that in class. You would let u be x cubed, and then x to the 6th, you could express it as u squared to get back down to a quadratic. X cubed you could express as just plain old u. And so now you're looking at like the quadratic function that you're familiar with. So from there you factor it now that it's in a simpler form. And you get a factor of u minus 27. And you get a factor of u plus 1. So the only thing now is, you can't leave it as u's, of course. You got to get back into x's. But what did we let u be? We let it be an x cubed. So that means these very quickly turn into x cubed minus 27 and x cubed plus 1. And then just ultra annoyingly, these are both a difference of cubes and a sum of cubes, and both of those factor 2. So to factor the difference of cubes, you know it's going to factor down to a binomial and then a trinomial. And I want the cube root of the first term, which is x, cube root of the second term, which is 3. Then in the trinomial, I want the cube root but squared, so an x squared. The last term is the cube root of the 27 but squared, so 9. And the middle term is the product of those two cube roots, so x times 3, which is 3x. And then for the pattern of signs, we said you could use that mnemonic device SOAP, SOAP, which stands for same sign. So for a difference, we'll go with a difference. Then you want the opposite sign. So for a difference, we'll go with a sum. And then you want to just always plus. So this last one will be plus. So everything here in orange is only the factored form of that first difference of cubes. Now we still have to factor the other one. I don't know, I'll do it in lighter orange. So it's going to be another binomial and then a trinomial. My cube roots this time are x and 1. X squared, 1 squared, x times 1 is x. So that's easy enough. And then following SOAP, it's a sum this time, so the same sign would be a sum. Then the opposite sign would be a difference. And then always plus would be, well, always plus. There's all my factors. I'm not sure how I'd prefer you to do this. I mean, I guess you could stop. This is not terribly pleasing to the eye, though. I think I would like to see the linear factors come first, probably. If I was going to neaten this up, I think I'd probably go x minus 3, x plus 1. Just get them together. Then I'd do the two quadratics. So an x squared plus 3x plus 9. And an x squared minus x plus 1. I don't think there's a difference between the orange answer and the blue answer. Literally just aesthetics here on the blue. I'd rather see a linear, quadratic, although a case could be made for reversing that and doing the quadratic, the linear. We do tend to see things in descending order of powers, right? But if we're splitting hairs here, it doesn't matter. Just get it down to these 4 factors. Moving on to 5. 5 is the same as 3. It's another one that's quadratic in nature. I'm going to skip the U substitution this time just to see if you guys can hang. Clearly to get x to the 4th, it's going to be an x squared and an x squared. Sort of clearly. If you want to get a 13 out of factors of 40, it's going to be an 8 and a 5. Right. Yeah, that's it. Now, I would say we're done here because obviously 8 is not a perfect square. So this is not a difference of perfect squares. 5 isn't a perfect square either. But I'll mention again that I did see on an answer key that Ms. Butler provided that sometimes it is sort of appropriate to factor this. Just kind of force it and just say, well, just put the square root of 8, right? And same with the 5. I mean, you might do this. If you were solving an equation, you might do this. Just to more clearly illustrate that our solution set is 4 things, right? Our solution set is a negative root 8, a positive root 8, a negative root 5, and a negative root 5. Oops, positive root 5. That's kind of the only reason I can see. If you just wanted to sort of force the factoring to find all 4 solutions, go ahead. But I just wouldn't do that. I wouldn't do it ever. I would stop on the red for sure. To me, factoring is always supposed to be over the set of integers. If you're giving me non-integer values in any of your factors, then you're factoring too far and you're pushing it. So I wouldn't. But now that it's written on the board, before you guys think me a fool, something like root 8 is not something you're really supposed to ever have. You are supposed to reduce radicals. So, for any of you who forgot how to do that, to reduce a radical, you're looking for perfect square factors of the radicand. So 8 obviously has factors of 1 and 8, 2 and 4, and that's it. 4 is a perfect square. Hopefully you're recognizing that. So root 8 can be broken down to square root of 4 times 2, which can be broken down to a square root of 4 and a square root of 2 separately. You're allowed to do that with multiplication. You just take the square root separately. That gives me normal plain old 2, the integer, and then a factor of root 2. So technically, if you ever gave me root 8, I might mark you down if you didn't factor it, right? So that's all the other reason to just stop there. And you know what? Let me just take all that crap, huck it in the bin. This should have been your final answer. Let's do 7. So for 7, always factor out the GCF first if you have one, because right now you're looking at something to the power of 6, which might be messing with your mind, until you realize you can just factor out an x squared. And then you have x to the 4th minus 4. Yeah, forgive me, my 4s often, when I'm writing small, the tablet that I'm using to write with will connect the top like that, and it can look like a 9. Just know that it's not a 9. You know that that should be 4, so chalk it up to my not so great tablet. You just saw it happen right then, so you know I'm not lying. Anyway, you now have a difference of squares, so factor it. X to the 4th is a perfect square, just the same as x squared is. So bring down the x squared. He just comes along for the ride. This will give you an x squared plus 2 and an x squared minus 2. And again, depending on how deep into the weeds you want to go, you could force the x squared minus 2 to an x plus root 2 and an x minus root 2, but I'm not doing that. I say there's nowhere left to go from here, so just give that as your answer. Number 9. This looks like another sort of straightforward quadratic in nature problem, so I'm going to go ahead and let u be x squared. So this is 2u squared plus u minus 6, and then I can factor that. Again, because I have a leading coefficient, because there's a value here other than 1, I want to multiply. So 2 times negative 6 is giving me negative 12. I want to find factors that add up to positive 1. So 1 and 12 ain't going to do it, that's 11. 2 and negative 6 ain't going to do it, that's 4. 3 and negative 4 ain't going to do it because that would give me a negative u. But if I do a negative 3 with a positive 4, then those are the ones I need. I guess I'll just say, you guys in class for the most part told me that when y'all do this, you split the middle term and you treat it as a minus 3u and a plus 4u. And then you factor by grouping, and there's nothing wrong with this. This approach is fine. That's not a 9, that's a 4, remember. I know I pointed it out and everything, but it still bothers me, so there, get rid of it. Okay, factor out your GCF. So you can factor out a u and have 2u minus 3. And if we did this right, if it's going to work, then I factor a 2 out of this, and I get 2u minus 3. At which point I can factor out the 2u minus 3. And when I factor it out, I'm left with just the u, and I'm left with a plus 2. And that's going to be my final. Oh, super psych, that is surely not my final factored form, because we let u equal x squared. So actually, my final form should be 2x squared minus 3 and x squared plus 2. That's it. If you guys like that method, go ahead, by all means, keep doing it. I'm going to point out, though, how to maybe get from here to here a little more directly. I just kind of guess and check. If I've got 2u squared plus u minus 6, then I know I'm looking for the product of two binomials. I know the only two terms that are going to give me 2u squared are a 2u and a u. And I also know that I'm after these factors when I do my outer and my inner products. So I've already got a factor of 2, so to get the 4, I know I just have to plop a 2 in this position, and it should be a positive 2. To get the factor of negative 3, well, when I do my inners, I'll need a factor of negative 3. And, oh, I'm done. That's it. Oh, well, super psych. Make these x squareds again, of course. But that's it. You can kind of just guess and check your way to where the term should go. And I would like you guys to practice that. I think it makes factoring these types of problems much simpler. So consider doing that. I'm on 9. Let's go to 11. Looks like a factoring by grouping problem, and guess what? You guys were good at those. So I'm going to blast over through this, frankly. Um, group these, factor out an x squared. Great. 4x minus 1. Awesome. From the other one, factor out just a negative 1 again. Interesting. Exactly the same as before. 4x minus 1. I noticed a lot of y'all, you kind of do this. I think you guys just like to grab the first things. So you go x squared minus 1, and then you keep the other factor, 4x minus 1. And that's fine, as long as it's not just like magic to you that you're doing that. Ideally, you would understand what I'm saying, which is that really, when we have these factors in common, you're factoring that out. That really should probably be the thing that you see in the front, so to speak. And then the x squared minus 1 are the remaining factors when that thing gets factored out. Doesn't matter. Super doesn't matter. Order doesn't matter. This is a difference of squares though, so factor it. X plus 1, x minus 1, 4x minus 1. There's your factored form. Okay, 13. Just another quadratic with a leading coefficient. So take the 5 and the negative 5. That's going to give you a negative 25 as your product. To get 24, it should be pretty obvious. You're going to go with a positive 25 and a negative 1. And that'll get you there. Again, using my method of guess and check. How are you going to get 5x squared with a 5x and an x? Literally, there's no other way, using integer coefficients at least. How are you going to get a 25 and a 1? I guess we're going to need a 5 in this position so that our outer product gives us 25. And if you'd like it to be positive, then you better saddle it with a positive coefficient. To get the negative 1, you just need a negative 1. And oops, I'm done. There's my factored form. Obviously, this is far more efficient than factoring by grouping once you're comfortable with it. By the way, so far I've done the guess part. I haven't done the check part. I don't have to because I've done a bazillion of these because I'm old, but you guys might want to actually double check that you've done it right. So just FOIL it. Do the first times the first, 5x squared. The outer is giving me 25x like I wanted it to. The inner product is a negative x, and the last product is a minus 5. So will that give me 24? Yes. The first term's right, last term's right, middle term's right, so I'm right. You can guess and check. Okay. 15. Boom. More of the same. Let's multiply a by c. So 4 by negative 15, that's negative 60. I'm looking for a middle term of 4. That essentially means I want these two factors to be 4 apart. So I've been telling you guys before, start at 1 and 60 and work methodically. But this is when my two terms are furthest apart. This is when my middle term would be greatest. So you actually want to be a little closer together here. So 60, like the 5 and the 12, 6 and 10, there it is. There. That was a little more efficient, right? But not that it matters. I want a positive, so we're going to go positive that, negative that. And then let's do this. So I stick my foot in my mouth here a little bit, because this time when I go to guess and check, there's actually two options. To get 4x squared, you might be going 4x and x, but you might be going 2x and 2x. And the answer is maybe both of these work anyway. Probably they do. No, they don't. Because if you want integer coefficients, then what times 4 will give you 6? No integer will. What times 4 will give you 10? No integer will. So you definitely want to set yourself up with the 2's. And then if you want a negative 6, you plop a negative 3 here to give the negative 6. You plop a positive 5 here to give you... Oh, I'm done. There you go. There's your factor form. Box it up. Move along. Factoring is easy. Okay. That's fitting. So this is the last problem from your actual homework. And this is a difference of cubes, but it's expressed a little weirdly. I despise leading... Oh, by the way, the equals 0 is just a typo. These are all supposed to be expressions, to factor, not equations to solve. So just get rid of that equals 0. That's a mistake on our part. Now, dealing with the leading negative, you got two options. You could just change the order using commutative property and just go 125 minus 64x cubed and then factor from there. Or you could factor out the negative 1. I guess my preference is to flip this rather than having a factor of negative 1 just chilling in the leading position all the way down. So that's what I'm going to do, I guess. So I already told you to factor a difference or a sum of cubes. You should expect a binomial and then a trinomial. The terms of these will be the cube root, so a 5, the cube root, so a 4x. Then the first term will be the cube root of this, but squared, so 25. Then it'll be the cube root of this, but squared, so 16x squared. And the middle term will be the product. It'll be, the a times b, so 20x. And then, of course, we follow the SOAP mnemonic to get our signs. So this is a difference. So the same sign would be a difference. Opposite sign would be plus, and always plus. So that should be our factored form. Yeah, that's it. That's it. That's the whole homework for the odds. So at this point, go ahead and just click the video off. Maybe put a comment in that says, hey, thanks, Mr. F. This was really great. Can't believe you spent all this time on this. I mean, that would certainly make me feel like the time I'm spending is well spent. But you don't have to. Those of you that want to see the evens, it's just if you feel like you need more practice, right? Ideally, stop watching me do them. At this point, click. Take a look at 2. Do it yourself. Pause the video. Do it. And then watch me do it to see if you're right. Same with 4, blah, blah, blah. Anyway, I'm going to do it for you, like I said. Looking at this, it's another quadratic in nature one, so I know I'm going to have a factor of x squared times x squared to get me my x to the 4th. The factors of 15 that are going to get me a negative 2 are going to be a negative 5 and a positive 3. I'm done. I'm just guessing and checking my way there. Not even really checking because I know I'm nailing it in one shot, so I'm not checking. You guys should check. This one certainly looks like a factor by grouping scenario. So I'll factor out next to the 4th to be left with x squared plus 2. Then I'll factor out just a negative 16, it looks like, to be left with x squared plus 2. Then I'll factor out the x squared plus 2's. And factoring them out leaves me with an x to the 4th minus 16, which super annoyingly factors down several more times. That's a 4th power. So mercifully, the sum of squares cannot be factored. It'll stay x squared plus 2. This, however, factors down to x squared plus 4, which as a sum of squares doesn't factor, but our other factor is x squared minus 4. Which as a difference of squares factors more. So you're going to have an x squared plus 2. You're going to have an x squared plus 4. And then an x plus 2 and an x minus 2. So again, order doesn't matter, but make sure I'm getting all 4 of those factors. Quadratic, quadratic, linear, linear. 6 and 8. Another factoring by grouping. Factor out x to the 6th to be left with x cubed minus 1. Factor out negative 1 to be left with x cubed minus 1. And then factor out the x cubed minus 1 to be left with x to the 6th minus 1. And then, I don't know, from here, moan loudly because obviously we're going to factor this and get another hunk of junk. This is a difference of cubes, so it'll be x minus 1, x squared plus x plus 1. That's this thing factor, but now this is a difference of cubes as well. Okay, so annoyingly, this is a difference of squares or a difference of cubes. Let's do it as a difference of squares, right? It would be x cubed minus 1 and an x cubed plus 1, which is where you see the moan and groan coming in, because you now know that's a difference of cubes. You can factor it. This is a sum of cubes. You can factor it. So by the time we're done, we're going to have a linear, quadratic, linear, quadratic, linear, quadratic. We're going to have 6 factors in all. So nothing to it but to do it though. So here we go. Bring down your x minus 1. Bring down your x squared plus x plus 1. Factor the blue one and you get x minus 1, x squared plus x plus 1. Factor the orange one, you get x plus 1, x squared minus x plus 1. Anything to collapse here? X squared plus plus. There's an x squared plus plus, so those are the same. So those can be collapsed and expressed using an exponent. These can be collapsed and expressed using an exponent. And these are different. So the best we can do to express our answer is the x minus 1 squared and an x plus 1. Then an x squared plus x plus 1. That's squared. And then an x squared minus x plus 1. So box that up. So it looks like we've got, what, 4 factors, but we don't, because this is 2 factors. So 1, 2, 3, 4, 5, 6. Whatever. That's kind of a pain in the butt one, but that's okay. That's the point, right? You guys are in the honors pre-calculus class, so you're supposed to see some of these weirder options. And then when you see the easy ones on testing quizzes, you'll be all the more prepared for them. So I didn't leave myself a ton of room. Well, this is a video. You can always rewind it. So let me just shrink all that, get it out of the way. Yoink. Hey, if you can't read that, rewind the video back to a time when it was bigger. For number 8. It's quadratic in nature. Let me do the u substitution just to make this look a little more friendly. This would be a u squared plus 14u plus 45. So you're just factoring as normal. What are the factors of 45 that give 19? 45 doesn't have that many factors. Is it 1 in 45? Nope. How's about 3 in 15? Nope. How's about 4 and, oh, what am I talking about? 5 and 9. Yeah, that's it. So just factor. This one's pretty straightforward. So you're going to have a u plus 5 and a u plus 9. And since we let u equal the x squared, these are really going to be x squared plus 5 and x squared plus 9. And with this being a sum, we don't have to factor any further. Only differences of squares are factorable. End of the line on that. 10, 11. Another straightforward quadratic, but you do have to multiply. So 2 times 20 is 40. Factors of 40 that give 13 are 5 and 8. That one's feeling a little suspiciously familiar. Is he the exact same one? Guess not. Not exactly the same. Here we had 40 trying to get 13, but we're getting at it a little bit differently this time. So okay, whatever. I'll allow it. But I know that when I factor this, I'm going to want a 2x. and an x. We already said we were aiming for factors of 5 and 8. So you'll get the 8 by placing a 4 right here. You get the 5 by putting a 5 right there. You want a negative in the middle, then they need to both be negative. And don't worry, the two negatives multiply to make a positive. So that's it. That's our factored form. Whoa. Sorry, my tablet does that sometimes. There you go. 12 just looks annoying. Was there any chance we could just not do it? I don't feel like doing it. All right, here's what I know. That's a perfect square. That's a perfect square too. So it's probably that, where it's a 2x and a 15. So no, it's just not that, because that would give me a 30 and a 30. Is there even a way to get 61? I honestly don't care. You just wouldn't be given numbers this big. There's no common factor you can factor out. Nah, we're just not doing that. Nope, not gonna spend the time on it. Moving on. Boink. How's about 14? This time I'm getting 100 and I want a 29, so it's 25 and 4. Okay. Because 5 times 20 is 100. And you want that, it'll be 4 times 25. Why'd that come to me so quickly? I don't know, it just did. If that didn't come to you quickly, then you'd be more methodical. You'd go 1 and 100, no. You'd go 2 and 50, no. You'd go 3 is not even a factor. 4 and 25, got it, right? We talked about that procedure, just starting at 1 and increasing by 1. So whatever, it's 4 and 25. And then I still like my method of guess and check. To get that 5x squared, you know you're going to want a factor of 5x and a factor of x. And who should multiply with the 5? Well, you want a 25, so you'll put a 5 there. You want a 4. So I now have an outer product of 25 and an inner product of 4. Everything's plus, so everything can be plus. There's my factored form. And now 16 is another factoring by grouping, pretty obviously. Yeah. So factor out an x squared, but there's also a GCF among the coefficients. It's just 2, but factor out the 2 to be left with 5x minus 4. And the same thing should happen here. Our GCF appears to be 5. So factor that out, you get 5x minus 4. So you can factor out the 5x minus 4s. And you'll be left with a factor that contains the 2x squared plus 5. And that's it for the 16. We've got one last problem. It's number 18. Again, it's just another one that's quadratic in nature. If you want to do a U substitution, you can. Then you're going to multiply 8 by 3 to get negative 24, and you're looking for factors of that give 10. Let's be methodical. To get 10, 6 and 4, right? But let's be methodical. 1 and 24. If one of them's negative, that makes 23. That's wrong. Negative 2 and 12. Oopsie daisy, I was wrong. So it's not the 6 and the 4, because we have to be negative. So the sum of 4 and 6 is 10, but because it's negative 24 and you have opposite signs, we're really looking for the difference. So good thing I checked. We definitely want those. And then we break this down. Again, we're faced with two options, whether we want the 8u with a u, or whether we want 4u with 2u. And again, it's an easy choice. Just look at the factors you're given. Can I do 8 times an integer to get a 2 or a 12? The answer is no. So if we're after only integer entries, which we definitely are, we're going to go with the 4 and the 2, because 4 times 3 will give me the 12 that I want. And 2 times negative 1 will give me the negative 2 that I'm after. So that all checks out. This was never actually an option. This is my factored form. We've got to substitute back in x squared for u though, giving us 4x squared minus 1, at which point we groan because that's a difference of squares. And this is 2x squared plus 3. So that factor is safe. He doesn't break down any further, but this one does. So you'll have a 2x plus 1, a 2x minus 1, and a 2x squared plus 3. And for probably the final time, I don't care about the order. I don't care if the quadratic comes first. I don't care if the plus comes before the minus. I just need these 3 factors written in any order. So there it is. There's your first homework walkthrough video. Like I said, I'll try to make these for basically every single homework, but keyword is I'll try to do it. It's kind of a lot of work, set up the camera, record, encode the video, put it up on YouTube, and find the link, post the link. It's a lot. So I will do it for many homeworks, but maybe not all. Anyway, again, for real, if you guys appreciate this, if you guys blow up the comments and tell me, hey, this is super helpful, that really will do a lot to make me want to do it. Having the views is fine, but if all I have is the views, I'm going to wonder if one dude is just watching it 100 times. If I actually hear from a lot of you, even if all you type is thank you, TY, whatever, it lets me know that you were actually there and that you used it and you found it useful. And if you don't, that's fine. If you don't, then ignore it. I'm not telling you have to watch it, but if it's something you want me to continue doing, then a little positive reinforcement for me, I might actually need it. Anyhow, this is Dragon On. Goodbye.